Welcome to the FPGA hardware design flow for SmartFusion. SmartFusion Intelligent Mixed Signal FPGAs are the only devices that integrate an FPGA, an ARM Cortex-M3 processor, and programmable analog. This video covers the basic steps of creating a SmartFusion hardware design using Libre IDE. It will show you how to create a SmartFusion project and configure several MSS microcontroller subsystem peripherals, including the fabric interface peripheral that allows you to connect the MSS to other logic blocks on the Smart Design canvas. The logic blocks can be cores from the Libre IDE catalog or user-created HDL blocks that have been imported into the Libre IDE project. Before starting your SmartFusion hardware design in Libre IDE, you should predetermine the IP cores that you will need for the design project and make sure they are downloaded from the Actel web repository into your local PC IP vault, typically located in the Actel Common folder on your C drive. For this project, the local IP folder already has the SmartFusion microcontroller MSS, Core APB3 bus interface, Core APB SRAM, and Core UART APB downloaded and available in the Common folder on the C drive. Start the design flow by creating a new project and giving it a name such as My First SmartFusion, and then selecting SmartFusion, A2F200M3F, and 484 FPGA as the family, die, and package type, and then click Next. Confirm or edit the tools you intend to use in your project. The Files menu enables you to import files into the project. Click to see the report of all the choices made via the new project wizard. Click Finish to close the wizard and start the project. Since this is a SmartFusion design and a key component of a SmartFusion project is the microcontroller subsystem, the Add Microcontroller Subsystem to Your System dialog box opens. Make sure the checkmark is checked and add the name MyMSS and click OK. And the SmartFusion MSS configurator opens and all MSS peripherals are exposed, just as they are displayed in the block diagram shown in the SmartFusion datasheet. Notice that the Smart Design MSS configurator has color-coded blocks. The blue blocks are for hardware configurations, the orange blocks are for firmware configuration and are only configurable in the software flow, green blocks are non-configurable, and gray-white blocks are disabled. Blocks that have a small checkbox in the bottom right corner can be disabled in order to conserve FPGA resources and power. Hardware blocks can be opened for configuration by clicking the wrench icon in the bottom right corner. This design only uses clock management, fabric interface, UART 0, and reset management peripherals. All other peripherals must be turned off by unchecking the checkmark at the bottom right-hand corner of the peripheral block. When using the fabric, you need to connect the fabric clock pin of the clock management block by right-clicking the fab_clock pin and selecting Clear Attribute. Then right-click again on the fab clock pin and select Promote to Top Level. Double-click the clock management block to view the possible configurations, but for this design we will accept the configurator default settings. Click OK when finished. This design also uses UART 0 in the MSS. Note that when selected, UART 0 already has predetermined connections to the top-level pins for the TXD and RXD ports. Click the Smart Design MSS Configurator I/O Editor tab to see the pin numbers and I/O attributes. The configuration of the UART is performed on the software development side using Soft Console or other software IDE tools. Next, click the Smart Design MSS Configurator Firmware tab. The Smart Design MSS Configurator knows what peripherals have been used in the MSS configuration, and the Firmware tab lists what instantiated cores need drivers. The instantiated UART 0 needs the MSS_UART_ driver. Note that if the driver text is shown as italicized, it needs to be downloaded from the Actel IP repository. You can right-click the driver text in the core type column to download the core. Next, right-click the M2F Reset N pin of the Reset Management block and select Clear Attribute. Then right-click again and select Promote to Top Level. Click the wrench icon on the fabric interface block. In this dialog, you can see the MSS and fabric clock frequencies as determined by the clock management configurator in the MSS. In this configurator, you can also specify the bus interface type, either AMBA APB3 or AHB Lite. For this design, we will specify the AMBA APB3 and the master mode. Click OK to close the configurator. To connect the MSS master APB port to the fabric, you must right-click it and select Promote to Top Level. We are now finished configuring the MSS for this design example. Click the MSS Generate button to complete the MS design and turn it into an HDL component. Close the Smart Design MSS configurator and note that the IP named MyMSS shows up as a design component in the Libre IDE Project Manager hierarchy and files list. The configured and generated MSS is now just another HDL block in your design files list, waiting to be instantiated onto the Smart Design canvas and connected to other IPs or HDL blocks, taking advantage of the SmartFusion Fabric programmable gates. To make use of the available SmartFusion Fabric, open the Smart Design by clicking the Smart Design button on the Libre IDE Flow window. Name the Smart Design project My Smart Design and click the OK button. The Smart Design canvas opens. Make sure that your Libre IDE catalog is visible and that you can view the names of the various IP cores. From the Design Explorer, right-click the MyMSS IP icon and select Instantiate in My Smart Design, or you can drag it onto the canvas. Note that the instantiated MyMSS component looks like any other instantiated block in Smart Design. Next, in the Libre IDE catalog, expand the bus interface category and drag Core APB3 onto the canvas. The Core APB3 configurator opens. Accept the default settings and click OK. Next, open the Memory and Controllers category and drag the Core APB SRAM onto the canvas. Again, accept the default settings and click OK. Next, in the Peripherals category, click and drag the Core UART APB onto the canvas. Change the TX and RX FIFO settings to enable and click OK. Now, right-click the Core APB3 bus interface instance and select Auto Connect Selected Instances. Accept the address settings on the Modify Memory map by clicking OK. Note that the key connections to the Core APB SRAM and Core UART and MSS have been made. Now, highlight all outputs of the Core UART by dragging across them, right-click, and select Promote to Top Level. Right-click the RX input on the left side of the Core UART and select Promote to Top Level. At this point, the logic design is complete. Right-click the Smart Design canvas and click Generate Design. This process converts the design into design rule checked and synthesis ready HDL code. From this point, you will follow the traditional FPGA design flow. Click the Simplify button on the Design Flow window to invoke synthesis. After synthesis, click the Design, Place, and Route button on the Libre Design Flow Guide, and Designer will import the netlist. When Designer opens, click the FlashPro Data File button to accelerate through the compile and layout and generation of the programming file. Accept or change the various dialogues that are presented as compile, layout, and programming file generation are automatically completed. Save and close the Designer project, and the Libre Design Flow Guide will note that you are ready to run FlashPro to program the SmartFusion FPGA. Click the FlashPro button and the FlashPro software opens. Various programming options are available for FlashPro software. As a minimum, you can select the Run button and select all default settings to program the FPGA. Please consult the FlashPro user guide for more information. Thank you for viewing the SmartFusion FPGA Design Flow video. Please use the links below to further explore SmartFusion.